Rebecca Graham, and today I'm going to give you a quick 10-minute lecture on some techniques for classifying soils out in the field. Now, before you even get into the pit, there are a couple things that I want you to think about. First, where are you? What's going on around you outside of the pit? What happened geologically to get you to where you are now? So first we can see, well, we're in Illinois. And that means that geologically we had some glaciation. The glaciers came through and made everything really flat. As you can see, the slopes are only about 0 to 2%, and you can confirm that with your clinometer. The next thing that you can observe is that we're in an agricultural field. We have some corn and some soy growing behind me, and that can give you some clues about what's going on in the classification of these surface horizons. We've had a lot of tillage and a lot of plowing going on for the last many decades, so that is going to change the soil classification. Another thing is you can notice it's quite windy right now, so that means there's going to be a lot of wind-blown silt or loess, and that is also going to change the characteristic of the soil. We're going to find a lot more silt in these soils. And lastly, the most obvious thing is we have ponded water right here, and that can give you some clues about the drainage. These soils are not very well drained, so much so in fact that, oh, what's this? We have a piece of tile drainage. So this is a hint that these soils are so poorly drained that in order to grow anything they had to put tile drainage underneath. So that is going to give you another hint about what's going on in these soils. So now we know we have flat soils in east central Illinois that are poorly drained, and they have been tilled for many years, and the glaciers came through and made it flat and windy. So now that we know some of these key characteristics about the area that we're in, which lead to some of the soil forming factors, we can now move into what's going on under the soil surface. So the first thing that you need to do is dig a hole. I've already done that for you. The next thing that you need to do is place your measuring tape and designate your soil horizons. I've also already done that for the sake of time. And in this lecture, I'm going to classify just the surface horizon. So the first thing that you're going to want to do is grab your trusty soil knife and stick it in the soil to collect a sample. So then you're going to want to break it up a little bit in your hand and see what it parts to. So as you can see here, we have a very good example of granular soil structure. And structure is the shape that your soil beds are in. So if you forget what any of the soil structures look like, you can always refer back to your field book for describing and sampling soils. This has a lot of pictures of what the different structures look like, as well as all of the other classification techniques that you're going to need to do the whole pit. Now moving on, after you've classified this as a granular soil structure, you're going to write that on your scorecard in the box as G. And the next thing that we're going to want to look at is color. So we can't do dry color because, as you noted already, it's pretty moist. So we're going to start with just moist color. So you're going to want to get a fresh ped in your hand, and then you're going to take your trusty Munsell book to figure out what color your soil is. So there are three components to soil color. The first component is hue, and hue you find from the page of your book. We are on the 10YR page. There's only one page in this book, but your book is going to have many more pages. 10YR is the most common soil color page, so you're always going to want to start on that page and go forward and go back from there. And the hue is the spectral color, the pure color, the red, orange, yellow, green, blue, purple color of your soil. So 10YR, that stands for yellow, red, 10 yellow, red, kind of a brown color. The next thing is your value, and that goes from 8 to 2 along the axis here, along the y-axis, and that shows how dark or light it is, how black or how white it is. And then the last value for the last component of soil color is chroma. That is, how bright is your color, how colorful is your color, how saturated, like you Instagram users know, is your color. So now that we know the components of soil color, you're going to delicately place the page under your fresh soil sample and pick the box that is closest to your soil color. And I've already classified this as a 10YR21, but you can figure that out for yourselves for the other soil horizons. So now that we know the soil structure and the soil color, we're going to continue on our charts. So make sure that you fill out on the chart, you're going to put 10YR for the hue value and the chroma. So the next thing that we're going to want to look at is soil texture. And if you remember, texture is the composition of sand, silt, and clay in a soil. And the texture affects how the soil comes together. So now that you have the structure and the color, you can start mushing it up in your hand. This is the most fun part. So the soil is already pretty moist, but we're going to have to get it just a little bit wetter so we can properly get the texture. So you want it to feel like fresh Play-Doh in your hands, and you're going to want to mush it around until you can form a nice ball. Depending on the soil texture, some textures won't make a ball, but you're going to want to aim for that. And then the next thing that you're going to want to do in order to figure out what soil texture you have is what we call the ribboning technique. So you guys have the flow chart for that here in your binders, but you're going to want to start with like a little bit in your hands, and then you're going to place it between your index finger and your thumb, and you're going to push it along to form a ribbon. The more clay that your soil has, the longer a ribbon you're going to be able to make. So we can see, based on the components of the flow chart, including the length of the ribbon and other components, what texture we have. We can also always consult the soil texture triangle when we have an idea of how much clay you have. And if you're absolutely clueless and don't know where to start, a good way is using the shine line technique. You take that between your thumb and your forefingers again, and you push it along. And if you see any shine or smoothness or reflection right here, then you have a shine line, and that means you have at least 27% clay. We don't have a shine line, so there's probably a pretty good chance that our soil has less than 27% clay in it. So now that we know that it's less than 27% clay, we can, using the flow chart as well as the soil texture triangle, come up with the texture. I've classified this as a silt loam, and then you can write that on your scorecard. So the next thing that we want to do is soil consistence. You're going to want to take a fresh ped from the pit and get a nice ped and put it between your index finger and your thumb and give it a smush. And if it's easy to smush, then it's friable, and if it's hard to smush, then it's hard. And the classifications for all the consistence are also in your field book. So I've classified this as friable because it broke very easily in my hand. And the last two things that you're going to want to look at when you're classifying a soil are redox features and clay films. Now, we don't have any redox features and clay films in the surface horizon because those primarily happen in the subsurface horizon. Redox features happen when a soil is saturated for long enough that all of the oxygen is depleted and microbes consume iron and manganese, so then you're going to get red and black mottles as well as depletions. And clay films happen when clay moves, translocates through the soil profile and deposits along peds. So in the subsurface horizon, we see examples of both redox features and clay films because the soil is saturated up to this point and the clay has moved down to this point. So we don't have any clay films or redox features in the surface horizon, but we definitely have them in the subsurface horizon. So now that we have talked about all of the different components of the surface horizon, we can classify this as the AP horizon of the Drummer Soil Series. So thank you for listening. I hope you learned something about soil morphology, and have a good day.